Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will find if the series below, which is the sum of n equal to 1 from 1 to infinity of 2 to the power 2n times 3 to the power 1 minus n, if it converge or diverge. Before we start, I know here I'm going to use the geometric series, but let me give you a brief explanation about the geometric series. I know a geometric series look like this: sum of n equal 1 to infinity of a times r to the power n minus 1. And that series, it's equal a plus a to the power of a times r plus a to the power r squared plus a to the power r to the power of 3 plus na. So for that series, if the geometric series, it converges if my r here, the absolute value of my r is less than 1, and the sum of that series would be equal, let's write the series, the sum of a r n minus 1 would be equal to a divided by 1 minus r. So the a is the first term and the r is the stuff that I multiply every time. So if you want here r to the power of 0, r to the power of 0 is 1, 1 times a is a. Okay, so now let's rewrite this series in a way that look like a geometric series. So the sum of n equal 1 to infinity of 2 to the power 2n times 3 to the power 1 minus n. I can write it as sum of n equal 1 to infinity of 2 to the power 2 and all that to the power of n times 3 to the power minus n minus 1. Because minus times n is minus n and minus times minus is equal to plus 1, so I rewrote it as if it used to be the original series here. So now that series would be equal sum of n equal 1 to infinity, or 2 to the power of 2 is 4 to the power of n, and because I have a negative exposures, I can bring it down to the denominator. It becomes 3 to the power of n minus 1. And here I realize on the numerator I have n and on the denominator I have n minus 1. So let's change the numerator to have it in a way to the power n minus 1. So that series is equal sum n equal 1 to infinity. I can do 4 to the power of 1 if you want times 4 to the power n minus 1. Because I have the same base, I have to add the powers. So 1 plus n minus 1 is 4 to the power of n divided by 3 to the power n minus 1. So that series would become sum equal n equal 1 to infinity of 4 times 4 divided by 3 to the power n minus 1. And if I look at my geometric series definition here, the geometric series definition, it's a, which is 4 to the power of 1, and then if n equal to 1 in that series here, if n equal to 1, I have 4 times 4 divided by 3. If n is equal to 2 is 4 divided by 3 to the power of 2, 4 divided by 3 to the power of 3, etc. So it is a geometric series. And I realize that my a here is equal to 4 and my r is equal 4 over 3. And since 4 over 3 is greater, the absolute value of 4 over 3, it is greater than 1, so that series diverge. If the 4 over 3 was less than 1, I would have find the sum using this formula here. The sum would be equal a divided by 1 minus r. But this one diverges, so I cannot find the sum for it. If you like my video, please subscribe to my channel. That would help me tremendously and would encourage me to do more videos for you. And if you push the like button, I would really appreciate it. Thank you for listening.